Hi everyone, welcome back to another example of integration by parts. Now this time we have to be a little bit more cunning with how we're going to approach this one. So we have sine squared. Let's just write that explicitly as the sine of x multiplied by the sine of x dx. Now normally we would look for this different functions, logarithmics, inverse trigonometrics and so forth. That's not going to apply this time, because both of these parts are trigonometric. So it's really not going to matter which one we call u. So u will be the sine of x. And then dv will be the remainder, sine of x dx. So just to highlight, that part is u, and this part, all of this part, is dv. So we literally we're looking here at the integral of u dv. Now, as normal, we'll go ahead over here and we'll take the derivative, du dv. Derivative of sine x is the cosine of x. So du will be the cosine of x dx. And likewise over here, we'll take the integral of dv to give us v. Integral of sine is negative cosine x. Don't worry about adding a constant of integration at that point, remember? Now, we've done the preparation work, let's write the rule. So remember, the integral of u dv equals u multiplied by v, subtract the integral of v du. So I'll just be sure that I write here, this u times dv was sine squared x dx. U is the sine of x, v is negative cosine of x, subtract the integral of v is the negative cosine of x multiplied by du. Well, du is cosine of x dx. Let's just keep working and see where this leads us. I have negative sine of x cosine of x. That part's not a problem. By the time I translate this, it'll be plus cosine squared x dx. Now that doesn't seem to be much good. We've started with the integral of sine squared, and instead we have to find the integral of cosine squared. How does that make our life any easier? Well, we've got a couple of tricks up our sleeve still. Let's not just throw in the towel yet. So we have sine of x cosine of x. Now what if we use the Pythagorean theorem to write this as 1 minus sine squared of x dx. Remember, it's the integral of all of that. So negative sine x cosine of x. And the integral here of a sum, remember subtracting is just adding a negative, so it really is a sum. That can be split as the integral of 1 dx minus the integral of sine squared x dx. Now it looks like I'm going in circles, doesn't it? Because I started with sine squared of x dx, and now I've got an integral involving sine squared of x dx. On the other, how can I evaluate this if I couldn't find sine squared in the first place, and now I end up needing to know sine squared? Well, we're actually closer to the answer than you think. What if I add this term? What if I add this to both sides? I will end up with 2 times the integral of sine squared x dx equals negative sine x cosine x. Now what's the integral of 1? Well, that's just x plus a constant of integration. Well, to find my answer, I just need to divide by 2. The integral of sine squared x dx is 1/2. Now let's write this x first, minus the sine of x by the cosine of x plus an arbitrary constant of integration. So really, it worked out fine in the long run. Now, what's a couple of important differences here that we haven't seen before? Well, this idea of LIATE didn't apply because both parts of our original integrand were trigonometric functions. This only works when we have parts which are of different types. And the other bit that happened here was that our original integral, which was here, integral of sine squared, through a little bit of trickery, reappeared on the other side of the expression, importantly with a negative sign in front of it. This way we could add it to both sides rather than evaluate it, because that was the whole question, was to evaluate integral of sine squared x dx. We could add it to the left hand side, giving us double what we were looking for. And then of course, just by dividing by 2, we have our answer. So there is a number of extra little tricks that we need to be aware of when using integration by parts. That's just one of them. See you next time.